Hello! During my motorcycle trip around Poland, I damaged my drone. The front left arm broke, so today I'm replacing it. Maybe this helps someone fix theirs on their own. First, there are two Phillips screws to remove. Next, I remove the gimbal cover. There are two T5 screws to undo. Now I remove the side gimbal covers. One of them is cracked. Fortunately, I bought a new replacement part as well. For the second one, I first bend it slightly from the top, then unclip it from the bottom. To remove the lower part of the housing, I use a simple phone opening tool that I had nearby. It's best to start prying the plastic in places where you don't have to force the tool in. This way you avoid deforming the housing. After loosening it initially, the cover can be fully removed by hand. To avoid damaging the electronic inside, I loosely place it back in position. I begin removing the upper shell at the point where the rear arms connect to the body. It's worth gradually unclipping the mounts until this part can also be safely separated. The foil where the adhesive has already failed is set aside. It probably serves as EMI shielding. I turn the drone over and unscrew the optical sensor, which is secured with 4 Phillips screws. To remove it, you also need to disconnect its connector, which is secured with glue. I managed to scrape it off. If you have a hot air station, you can hit the glue in that spot. The sensor is now removed. I place the screws back into the holes so I don't lose them. Now I disconnect the 2 small connectors that are accessible. I flip the drone over and remove the Phillips screw from the metal shield. Then take the shield off. I also removed the adjacent screw. I tried to remove the heatsink, but first I need to disconnect the GPS module connector. The blue substance is thermal gel. The replacement arm I bought is used, so I hope it works. To install it, 3 wires will need to be soldered. Before that, there is still some work to do. The antenna cables coming from the front arms are connected to the main board and lightly glued in place. Fortunately, the glue peels off easily. More problematic is the housing slot where the cables are seated. The glue there needs to be heated. I managed to do it with a hair dryer, just heating it long enough. I directed the airflow at that spot for about 30 seconds. Using tweezers, I removed the glue and disconnected both cables on this side. I turned the drone over, and since I'm only interested in the black cable coming from the damaged arm, I pulled that one out. Next, I removed 3 screws from a small board deep inside the housing. To disconnect the connector attached to it, the glue must be removed. I go back to the main board and disconnect the connector that had a metal retention clip. I hid the glue in another spot where the cables pass through and loosen them. I do the same on the other side. What's left is to loosen the cables running from the arms to the board. Now the board can be slid out and prepared for soldering. Before soldering, the final layer of glue needs to be removed. Again, the hair dryer and tweezers do the job. I take the soldering iron and solder the connections, red, white and black wires. Then the wires can be pulled out, and I move on to the removing the arm, which is secured with 2 T5 screws. After removing them, the arm slides out of its mount together with all the cables. Now I install the new arm in reverse order. After tightening the screws, I route the black cable properly through the housing. Next, I position both antenna cables as they were before. I reconnect them and apply hot glue where they pass through the housing. The 3 wires that will be soldered need to be routed to the other side. After positioning them correctly, I can finally solder. I also apply glue to the soldered joints. The soldered board now goes into its original position. I align it with the housing and secure it with 3 screws. Next, I reconnect the connector that was previously detached from it. I also add some glue here to prevent it from coming loose. I reconnect the largest connector to the main board. The thermal gel is pliable but not fully liquid, so you can slightly improve its distribution. Now I slide the remaining cables into their proper places. I reconnect the smaller connector to the main board, as well as the one that connects it to the GPS module. Now this section can be fitted and screwed back together. Next, I reconnect the 2 smallest connectors. The remaining loose cables need to be organized. Once the cables are arranged, the optical sensor can be screwed back in. All that's left is reconnecting its side connector. The foil was previously glued in place, but the old adhesive no longer holds. I use adhesive intended for mounting phone displays. Now the housing can be reassembled. I start with the upper part. Press slowly and carefully. It was my first time doing this, and I managed not to break the clips, so you should be fine too. Now the lower part. I don't fully close it yet, which makes installing the side gimbal covers easier. I ordered new gimbal covers because one of mine was damaged. Installing these parts requires a bit more patience and precision due to the proximity of the gimbal. From what I noticed, it's better to clip them in from the top first, then from the bottom at the lower cover. Alright, the housing is almost fully assembled, only the screws and the gimbal cover remain. Now I replace the damaged propellers and install the missing ones. Luckily I have the correct set on hand. The screws in the set are new, which is important because their threads are coated with adhesive. I tighten the screws carefully. There is some slight play in the blades, but it's the same as in the others that weren't replaced. 2 more screws left to install. After assembly, I check whether all propellers spin freely. This allows you to test the drone's operation without taking off. Just a short flight test and the job is done. Thank you for watching and don't forget to subscribe.